Good afternoon, respected faculty members and my friends. First of all, I want to thank respected staffs for spending their valuable time with us to take a look in our project works. And also, I want to thank Robotics Lab of CEG for giving us an opportunity to do this mini project. I am Thiruvadi Dinesh Kumar from EC department doing second year.
Myself Sai Krishnan from EC department. I am doing second year.
Hello everyone, I am Srinivasan Babu from EC department and I am in second year.
Hello everyone, my name is Hariharan. I am studying ECE second year.
So, our mini project work is automated parking system. In this project, we have built a bot which automatically gets parked in the available parking space either in parallel or vertical fashion depending upon the slot length and width. The purpose of this project is to make the parking process automated, which helps in saving a little time in busy schedule of many people. So generally when it comes to parking, we all know we have to be very cautious and spend our time in proper parking without causing any damage to our vehicle as well as other vehicles parked nearby. In order to make this process easy and save some time, it would be better if we make the parking process automated. So that's what we have tried to implement in our mini project. We have used a normal chassis kit, Arduino Mega, motor shield and ultrasonic sensors in our work. As we have used a good number of ultrasonic sensors, damage can never occur while parking as the bot automatically stops and changes direction whenever it receives a message from ultrasonic sensor that the achieved distance with respect to nearby vehicle or wall may cause damage. So basically at first the bot will be stopped at the entrance from which it automatically moves and searches for available slots and gets parked automatically. In case if no space is available for parking, the bot automatically comes back to the entrance due to unavailability of parking slot. This is the overall idea of our project. The detailed version of working will be explained by my teammates, so I am handing over this platform to Srinivas for further explanation.
Now let's see about parallel parking. Parallel parking is a method of parking parallel to the road in line with other obstacles parked in the parking slot. It initially requires driving slightly past the obstacle which is present in front of that parking space and keeping a safe distance, and then reversing back into that space so that the vehicle gets parked perfectly. Okay, now let's see three main steps involved in parallel parking. The first step is the positioning of car. Positioning of car. In the manual car case, positioning is done by the mirrors and etc. So in our project bot case, this job is taken over by the ultrasonic sensors. The ultrasonic sensors firstly takes care of two parameters: the length of the bot and the width of the bot. Of the bot 27 cm and width of the bot 18 cm. The code written compares the length of the bot with the length of the parking space. The parallel parking algorithm gets triggered if and only if the length of the parking space is lesser than the length of the bot, that is 27 cm. Now the second step comes in parallel parking, which is the checking of mirrors. Checking of mirrors I told in reference to the cars which does not have automatic parking system inbuilt in it, in which the driver has to manually see the rear view mirror and then park into the parking slot. But in our automatic parking bot, this job is taken over by the ultrasonic sensor, more specifically the backward one, which sees to it that the bot gets parked without colliding with the obstacle which is present at the backward of the parking slot. Now comes the third step. The third and the final step in parallel parking is the backing up step. The backing up step, the ultrasonic sensor, more specifically the sideward ultrasonic sensor, measures the distance between the sidewall and the side of the bot. And the code written sees to that the bot maintains a safe distance from the sideward wall, which prevents it from colliding while parking. So this completes the three practical steps to parallel park which we have implemented in our bot. Now we will focus on the theoretical side. In theoretical side, there are four parameters which comes into picture which determines the minimum space required for parallel parking. The four parameters are W, which is the width of the car which is present in the front of the parking slot, and the R is the radius of the curb circle which a car has to make while doing parallel parking. K, the K value is the length between the front of the car and the front tire, and L is the length between the front tire and the rear tire. So the minimum parking space required for parallel parking is given by the expression like length plus an algebraic expression involving all these four variables. These parameters were also taken into consideration while building our bot. So this completes the parallel parking algorithm completely. Thank you so much.
Hello everyone, my name is Hariharan and I am going to explain about vertical parking. There are three cases in vertical parking. Case 1. First, the bot enters into the parking slot and it checks for a free available slot. Once a free space is detected, it checks the dimensions of the slot. If the length of the slot is greater than the length of the bot, that is 27 cm, and the width of the slot is greater than the width of the bot, that is 18 cm, then the bot is ready to park. By turning 90 degrees towards left and by moving forward and backward slowly, it gets parked correctly. Case 2. If the width of the slot is equal to the width of the bot, that is 27 cm, and the length of the slot is greater than the length of the bot, that is 18 cm, then the bot is ready to park by turning 90 degrees towards left, and by moving forward and backward it gets parked correctly. Case 3. If the width of the slot is less than the width of the bot, that is 27 cm, and the length of the slot is greater than the length of the bot, that is 18 cm, since the dimension does not match with the dimension of the bot decides not to park and goes in first for another free slot. This is the parking mechanism when the parking slot is at left side. If it is present on the right side, then the opposite case happens.
We have also added an additional feature to our bot. If the bot could not park in parallel or perpendicular manner, then it will assume that there is no slot available for parking. Then it will come back to the entrance. This will avoid unnecessary stoppage of bot in the midway of the road. Now let me conclude by saying few advantages and applications of our project. We can use this feature to save energy and time. It gets automatically parked in the parking space and helps us to avoid accidents as best obstacle avoidance mechanism. Vehicles will also be parked in a neat manner as it gets parked according to the dimensions of the parking slot. When vehicles become automatic, why not the parking system? Driverless cars will be a normal feature in future. So naturally, parking should also be driverless. Our project of automated parking system is a step in that direction. We can call it a futuristic idea, but this will become a reality in the near future. Henry Ford has said that nothing is hard if you divide into small jobs. So I thank my teammates who collectively produced this technical wonder. Our special thanks to mentor Mr. Abdullah for guiding us to complete this project. Our sincere thanks to Robotics Club of CEG. We sincerely hope that future vehicles will have this automated parking system. Thank you.